All right, so today I'm talking about proving identities. So I really understand what proving identities means. We need to kind of go back and review what you've been doing for like the last week and a half in this stuff. Okay? Just as a quick review, would you agree that 2 tests ago that test was like super easy? Just in case you don't remember, the average in the class was an A. So yeah, it was really easy 2 tests ago. Last test that you had, also pretty easy. Vast majority had A's and B's. Okay, this one's the tough one. That's why we've had already a week and a half on it, and you already got another, and you have another week before we take the test. Okay, so this is tough. Don't expect you're supposed to be expert yet. You don't have to test for another week. All right, so let's talk about some of the things you've needed to be able to do for simplifying. Here's the base kind of skills that you need to be able to do. Do you get that anything out there can be changed into a sine or a cosine? What about tangent? Well, can't you change tangent into what? Sine over cosine. What about like cosecant? 1 over sine. You get how everything can change into a sine or a cosine? Even things like 1. The number 1 can be changed into sine and cosine. Because you know that cosine squared plus sine squared, I should have a little theta in there, equals 1. So if I have a 1, I can replace it with cosine squared plus sine squared. So even a 1 can turn into sines and cosines. So changing everything to sines and cosines is really, really powerful. It works on like half the problems you have. Sometimes it's really messy when you do it that way, but it works. So at least know that strategy. Now, I realized like most of the way through this list that I didn't emphasize this enough. I am now telling you how to get an A on your test in a week. If I were you, I'd be writing down some of these ideas because they're kind of important. There's a lot of things on here that are going to come up. All right, changing everything sines and cosines is powerful. How about difference of squares? It doesn't seem like that big of a deal. I hope you remember it. It's like this. Do you remember you could factor that into what? X squared minus 16. Do you know how to factor that? If you don't, so you not have a chance on half the problems. I bet you if I remind you for 2 seconds here, you'll remember it. It's x and x, because that's the square root of x squared, and square root of 16 is 4 and 4, and you do a 1 plus and 1 minus. Does that ring a bell? I know you've learned this. Okay, so then let's try the little bit harder variety. Let's say it was x to the 4th and 16. Is that still the difference of squares? Yes. What would the x to the 4th break into here and here? X squared, and then this would turn into minus and plus what? 4 and 4. And then you see how from there we could break it down again? Look at that one. Isn't that a difference of squares? See how that could break into x plus 2 and x minus 2? You get that? All right, so what if you see this? Sine squared theta minus 1. Is that a difference of squares? Yes, it is. Difference just means minus. And isn't this a perfect square? It's something squared, just like x squared. Well, the one that's probably freaking out is 1, but isn't 1 a perfect square because 1 times 1 is 1? Would it make you feel better if I put a squared there? 1 squared is the same as 1, right? Okay, so do you get that that one could be written as what? Sine theta plus 1 and minus 1. All right, that isn't super complicated. It's just saying that, oh, this is a square, that's a minus. And I can break it up into 2 things then. Why would that be handy? Because what if this was in the middle of a problem that looked like this? Sine theta minus 1 on the bottom, and then all that other stuff on the top. You see how now, oh, look, that'll cancel that. Now the answer is sine squared, or sine theta plus 1. So you need to be able to do that. So when I say, you're not going to have something this simple. That was when you were in higher algebra. You'd be just going like this. What you're going to have now is instead of x squared, you're going to have 6 squared. Secant of x squared. And And you would then break that up into secant x plus 4, secant x minus 4. And really that squared should be right there. But anyway, hold that thought a sec. Okay, so how about this one? Secant squared, no, let's do sine. Sine squared of x minus cosine squared of x. Do you get that that's a difference of squares? It's got a minus. They're both things that are squared. Yeah, so I can do one of these deals to it. Would it help me sometime? Yeah. What if it was sine to the 4th? Are they still differences of squares? Yes. I'd like you to try that one right there. Break it down. I felt like it was an 80s song for a second there. Break it down now. And I think you'll notice something will happen. If you do it right and you notice that, oh, I can simplify this further. One's plus and one's minus, right? What's the square root of sine to the 4th? Say it if you know it. Sine squared. How about that cosine to the 4th? Well, that's just going to be cosine squared. Does anybody notice it? What? What's that? 1. So 1 times all of that is just all of that. That is your answer. Sine squared of x minus cosine squared of x. Could I, if it would have helped me in the problem, factored that farther? Yes, I could. Because is this a difference of squares? Yes, it is. All right, so I'm just showing you a little tool that you could have used last week and you can use next week and you'll be able to use on today's homework. It's just a little trick, a reminder about difference of squares. All right, so let's say this would be sine of x and sine of x. And then the other one is cosine x, and this is plus and this is minus. Now, is that any simpler than it was before? No. So I could have probably just left it this way. But what if in the problem it had had like a sine x minus cosine x? Sine x minus cosine x. If it had had that, then this would have been like, oh, perfect, I can cancel that off, and now there's my final answer. All right, so that's just one trick that I spent like 5 minutes on. Why? Because it's important. So look for difference of squares. Next thing is factoring. We already talked about factoring with difference of squares, but can you factor things like x squared plus 2x plus 1? I hope you can. If you don't know how to factor that, plus 1, then you'll be really in trouble when it's sine of x squared and 2 sine of x. Because if you don't get basic factoring, you really won't get it when it's got quadratics and trig functions. Canceling's pretty obvious. You just want, a lot of times you're doing, like, here's a canceling that maybe isn't so obvious. Sine of x times cosecant of x. Normally you think of something on the top and something on the bottom canceling, but why do these two cancel? Because they're reciprocals. So this is because it's really 1 over sine, so what do they cancel to? 1. This equals 1. Because cosecant's really 1 over sine x. And when I change sine x to, or when I change it to that, it becomes more obvious that these are canceled. And that equals 1 over 1, which is 1. All right, so canceling is kind of important. Next thing, rearrange to make good substitutions. I would put that on your little list of ideas for when you're stuck on a hard problem. Rearrange. I'll give you an example. let's make this, let's just change one little, let's just leave it to me. I'm just trying to make the point that this and this are just begging to be put next to each other so that you can do what? Turn it into a 1. Because sine squared plus cosine squared is equal to 1. So then it'd be 1 plus secant squared of x. All right. Next topic, multiplying by 1 creatively. When would you ever need to do that? A lot of times it's to find a common denominator. You can't add two fractions unless they have the same denominator. So here's a typical situation. Don't you agree you've seen this kind of thing before? Where you see a lot of fractions in this, don't you? Well, and if you see a lot of fractions in this, then you should know that one of the rules for fractions is you got to have common denominators to be able to add them together. Okay? So if I want this to have a common denominator of cosine, I got to know, first of all, what is the denominator over here right now? It's a 1. How can I get it to be a cosine? Multiply by cosine. So if I do that, this is the part where I said multiplying by 1 creatively, because if I multiply this by cosine down there, I have to also multiply it by cosine up here. Notice that that's equal to 1, right? So now, why did I do that? So that the bottom would become cosine x, so now I can actually add them. All right, I'm going to cheat and change this up here to cosine. It could have been sine, it's fine, but if I make it cosine, then here's a typical scenario. Now I've got the bottoms are both cosines. The top is 1 plus cosine squared x over the bottom is cosine and a cosine, so the bottom is cosine. And whenever you see this kind of a thing, oh, dang it, now I need to do minus. Sorry. I could have made this problem prettier by doing it this way, because then the top, do you recognize top? Top would change to what? Sine. All right, but what was my point there? My point was this part right here, that you can times by something over something. When do you do it? A lot of times it's to find a common denominator. All right, but wait, there's more. I'm trying to go through a lot today to try to review for you a lot of ideas on what you can do to like solve last week's problems and next week's problems. So I could just jump right to the thing for today, which is actually pretty easy, but I think this is good review for you. Finding good substitutions from identities. You got to be good at being able to see something and know what might swap out for this. So you really, to be able to do those substitutions, you simply have to know your identities. Let's go over a few kinds of identities here. Actually, I have that on a separate page right there. What identities do you know? Well, I hope this is the cardinal one. I should usually start with sine. It doesn't matter with the way it works. Sine squared theta plus cosine squared theta is equal to 1. So many things can come from that. Like if you just want to subtract the cosine and put it over here to the other side, then I'll have sine squared theta is equal to 1 minus cosine squared theta. So if I saw 1 minus cosine in a problem, then I should replace it with sine. Then there's a couple of goofy sayings that we taught you. Give me one of them. The one with the tan is what we seek. Do you know how you could get that from the original one? Were you told that or not? Okay, here's what you could do on that original one. If you divide everything by cosine, would you agree that in an equation that you can divide everything by something if you want to? Divide everything by 6 if you want to? Well, I'm dividing everything by cosine. Why? Because what's sine over cosine? Tangent. What's cosine over cosine? 1. And what's 1 over cosine? That's where that comes from. Okay, so I thought it'd be easier to just teach you the little nifty saying, the one with the tan is what we seek. But in case you ever forget those little sayings, because I know kids come up to me and say, I can't remember the stupid little sayings. And I won't tell you during the test. Okay, so you can just take the original one that everybody ought to know, sine squared plus cosine squared equals 1, and divide it by cosine, or you could divide it by what? And you divide everything by sine, you get the other one. Then, if I divide everything by sine squared, I would have the other saying, which is what? The one with the cotangent. The one with the coat is cosine. All right. These are used a ton. They're used more than anything else except maybe one other thing. What's another thing that gets used a lot for identities? Reciprocals. Yeah, the 1 over things. So like if you know that sine is 1 over cosecant, everything has something like that, right? So what's cotangent go with? 1 over tangent. Or cotangent could be instead of sine over cosine, which is what? Cosine over sine. Yep. All right. You need to know those. Tangent comes up a lot. Tangent of theta is sine theta or cosine theta, and cotangent is the flip of that. Okay, so you got to know all of those really well. There's a couple obscure ones that you don't use nearly as much. I don't want to waste your time talking about those today, but the ones that you just talked about there, those are come up a ton. All right. Ideas and what to look for. Anytime you see 1 plus something, it probably is one of those identities. Or 1 minus something, or something minus 1. Anything that's got a plus or a minus 1 in it, it's probably one of those identities cropping up. What is the one with the tan? Secant, what we seek. All right. Another thing. Anytime that changing everything to sines over sines and cosines is really, really powerful. So if you notice that I haven't tried this yet, I should just try changing it to sines and cosines, and a lot of times things will cancel out. All right, I want to get to a simplified problem. We've reminded you about a few of these. Hopefully this one will be fairly easy. Go ahead, give it a shot. This is just simplifying. You've done it before. Only pain in the butt with simplifying is you don't know when you're done. But a lot of times when it comes out to something really simple, well, you know you're done. If the answer ever just comes out to like tangent or something, then you're probably done. Now, if this one doesn't come for you, that means that you don't know your identities well enough. You need to memorize them and recognize them. Because right here, you should have right away seen that that was what? 1. Now, do you have to do it that way? No. There's actually a better way to do it. But I'm going to start with this way. This turns into 1. 1 minus, and then right away you should think, oh, 1 over something. That means just replace it with the other one. Instead of secant, what would it be? Cosine. And then that you should right away remember that, oh, Mr. Server said that if it's got a 1 in it, it probably is one of those identities, and it is, and what is it? Sine. Because it comes from this one. Equals 1. And then you just have to move the cosine to the other side and you'll see it. All right. There is more than one way to skin a cat. A terrible saying for a cat lover. But it's an old saying. You could have done this a different way that would have been probably faster. Do you get that if I change that right there into cosine? Uh-oh. Do you get that then I have a positive cosine and a negative cosine? And they'll just cancel out? And the answer is sine. Same answer we got last time. Just this way is probably a little faster. All right. The new thing for today is called proving. And it sounds really hard because proofs are generally something that's hard, especially if you did any in geometry. They can be hard. But these kind of proofs are actually very easy. because proving, look, it's the same exact problem you just had 2 seconds ago. Except in a prove problem, they would say that it equals sine squared. And you have to prove that. It's just exactly like simplifying, except you know what the answer's got to turn out to. Do you get what I'm saying? You know that when you're done simplifying this side, the complicated side, that it will turn into a sine. So it's the same exact problem, except you know the ending. Yes? Yes. Now, I'll just say it this way. The answer is the answer, and you don't need to simplify it further. So like, let's say that they asked me to turn this into sine squared over secant of theta. You don't have to try to think of, could I simplify that farther? You don't need to. If they tell you to make it into this, that's what you make it into. Okay, so the problem just, in a simplified problem, is just they give you the problem and they tell you the answer. It's just like the simplified problems that you had, that you were driving yourself crazy with like 4 days ago, except that you now know that the answers are ahead of time. You just have to show your steps to get there. One thing about these, that people see them and they think they're in a big equation, and so therefore I should be able to add something to everything, or both sides, or multiply everything by 5, or take the square root of both sides. You can't do any of those things. All you can do is simplify. This is not an equation. It is a proof. All right. And look at the answer to figure out where you're headed. If I have this big thing, and it turns out to equal 1, I have to prove that it'll equal 1. Well, don't like rack your brain about what to do. If it's a big fraction, do you get that if it equals 1, that the top and the bottom have to be equal to each other? So if you know that ahead of time, it gives you big hints on what you should do. Here's another common thing. Let's say that the answer comes out to cosine. You know the answer is going to come out to cosine. So if on the other side here you have cosine and tangent, well, better leave the cosine as a cosine, and you better change the tangent into something that has a cosine in it, because you know the answer's got to be cosine. All I'm saying is look at the answer, look where you're headed, so it'll give you clues on where you should go. All right. Prove that's true. You know the answer is 1. So all you have to do is simplify that left side. And if you know the answer is 1, just be smart about how you do it. That gives you big clues on what you should do. Yes? Oh, what I'll do is leave it on the board at the end of this recording, so you can just, I understand what you're saying. I'm just saying that I'll be glad to put that up at the, I'll try to remember at the very end to put it up, and if nothing else, you can go back in the video and you'll find it there. Because it's hard to post yeah, but you can look at the video. All right, so hopefully you are smart enough to notice that if that was only cotangent, then it would be true, right? If I can make the top cotangent, cotangent over cotangent would of course equal 1. So can I make the top into a cotangent somehow? To me, that means maybe I should make it into sines and cosines first, because that's what cotangent is made up of. So what should I do? Give me something simple I could do. Yes? Change the cosecant. All right, you could do that, but I was just suggesting that we make the top turn into cotangent. Because see, the bottom is cotangent already. Your way would have worked. That's like I was saying, there's more than one way to skin a cat. You could have done it that way, but I want this top to be cotangent. Yes. Place this with 1 over sine. And now I'm going to rewrite it. Cosine of theta times 1 over sine theta over cotangent. Notice I don't have to like do anything to the right side. I just leave it alone. I could say equals 1. I don't have to. Do you get that the cosine times the sine will mean it's cosine over sine? And cosine theta over sine theta, all over cotangent theta. And the top is really cotangent. So now it's cotangent over cotangent. And that simplifies further to 1. Now, am I done? No. I would painfully have to mark this problem wrong because there's one thing that a proof always has to have at the end. Is a statement that you got it to equal what you wanted it to equal. Okay, I'm even okay with you skipping over the equals 1 here and the equals 1 here, but the very last line better be 1 equals 1. Get what I'm saying? That's the way you prove. You have fast thumbs, but not fast enough. Let me put that on my desk, please. I can complete the text later. All right. This one is just simplify. Try simplifying that one. I'll do a little rearranging first. Get how that and that guy go together? And what do they make? 1. And you get how that 1 and this minus 1 are going to cancel each other out? And it's sine over cosine, and then that simplifies to tangent. All right, good. Now, what would this have looked like if it had been a proof problem? They would have just said right off the bat that it's going to be tangent. And you do the same exact thing. But here's what kids like to do, and they get it wrong because of it. They'll see 2 or 3 things at once and go, oh yeah, this and this makes 1. 1 and minus 1 cancel each other out, and they go like that. And then they think that they got it. Tangent equals tangent. Marked wrong. Why? Because you have to show your steps. You have to show what you did. You can't just cross off a bunch of things. And what did I do? Well, my step the intermediary step I would have to have is that I took this and changed it into a 1. Okay? So that's bottom line is on proofs more than any place else, you have to show your work because I already know the answer is 1. You know what I mean? A lot of problems you got to figure out what the answer is. And these, you know the answer. The answer is tangent, of course. It's can you prove that it gets there? So you have to show work. This scribbling stuff out is not going to cut it for showing work.
Will there be proofs on the test?
Yes. All right. Let's do some of the homework. I said I would leave up that last slide, so I will. Here is that list of ideas. It's a little messy now. Maybe I can even clean it up a smidge. Your homework is a worksheet. And you know what? I might even do one more problem here, and I'll put that back up in a second. I'm going to do problem 1 off the worksheet with you to get you started. Sometimes when you started, you're halfway done. It's my daddy used to always say. Technically, it's never true, but it's still it's a much deeper meaning. All right, number 1, cosecant squared x 1 minus cosecant squared x. Sorry, cosine squared x has to equal 1. Remember that your steps are important and that the final statement must be 1 equals 1. So I got to get the left side to be 1. So if I know I got to get this thing to be 1, I should be thinking, I really would like to turn them into reciprocals. This times its reciprocal would equal 1, right? So I really just need this circle right here to turn into what? Sine. And if I could make that sine, and it is sine. Because I know that from one of those major sine squared plus cosine squared is equal to 1 thing. All right, so it comes from this. This is a fact you can use. Theta, theta. So then if that's really true, then 1 minus cosine, just put the cosine to the other side, should be sine. So this right here is sine. And now I can, here's how I would show my work. That's sine, this one's still cosecant. And I'm multiplying them together. And from here, I'd be fine with you just, since those are reciprocals, then you can just jump to 1 equals 1. I'm a reasonable person. Okay, so that's just one step to me. Because these are reciprocals of each other. When I times them, I get 1. If I wanted to, I could make you show what the next step, which would be that, you know, either change this one to 1 over sine or the other one to 1 over cosecant, but I'd be okay with you skipping this step right here. Because these are by definition reciprocals and therefore they will equal 1. Yes?
What if I went like, instead of that one, I went to the cotangent, which is 1 plus cotangent squared?
Where would you put a cotangent? Oh, for the cosecant? Okay, you could do that. So let me try this. It's an alternate solution being proposed here. Okay, so you want me to change that right there to 1 plus cotangent. The one with the coat is cozy. Yes, good. Times 1 minus cosine squared x. Can you make this work from there?
And then wouldn't be like 1 plus, would you cosine squared over sine squared, or just cosine and a over sine?
You could change this right here into cotangent is cosine over sine. It's going to work, it's just going to take you longer to get there. So I would do you see that this right here is just equal to sine squared? You see how that's going to be a lot quicker? Okay, so this other way would have worked. I would have to now, I'd have to do first outside, inside, lasts. Remember what I mean? Like that times that, and then that times that, and that times that, and that times that. It's going to be way, way, way longer, but it'll work. It's going to take a while. Okay, let's do another problem off the worksheet. Number 2. And it is cosine squared x minus sine squared x is equal to 2 cosine squared x minus 1. All right. Do you remember my tips? One was that if the answer, which is over here on the right, only has one function in it, do you see that that only has one function in it? Cosine. That therefore I should probably get this side to turn into only cosines, right? So therefore, any ideas? Get rid of the sine, right? What should I replace the sine with? How can I replace a sine with a cosine? There is a resubstitution you can do right there. It's really easy. Get rid of this and put in what? 1 minus, oopsie, 1 minus cosine squared. And again, if you don't see that, it's because you don't know this one well enough. Which also leads to any of these can be replaced, like the sine squared would be 1 minus the cosine squared x. Or the other sub one would be that cosine would equal 1 minus the sine. All right, these have to be like second nature to you. They're going to come up a lot. All right, now why is that good? Why that little substitution we did? It's because now I have a cosine minus a negative cosine, and that really means plus a cosine. What's a cosine squared plus another cosine squared? 2 cosine squareds. And then I have this leftover minus 1 right there. If I got a statement that's exactly equal on both sides, then I proved it. in case you didn't get what I just did there, I'm going to go back and show you real quick. I'm going to rewrite it nicer. That's what I have when I substitute out what I crossed out here, okay? Then I can rewrite it nicer. All I did there was distribute my negative to both parts. And now, cosine and another cosine makes 2 cosine. And that's exactly what I wanted it to equal. Drop that all the way down. See ya. I've done a proof. All right. I did the first couple for you. The next one, number 3, the hint I will give you, if you're trying to change that whole thing into secant, you have to change 2 parts, something plus something, into 1. Let me show you what I mean. Tangent x times sine x plus cosine x has to equal secant of x. Do you get that these two have to get added together to make one thing? If I'm going to add them together, don't I need a common denominator? Well, you might say it doesn't even have a denominator at server, but it will, because tangent you'll change into sine over cosine. And then you'll have, this whole thing will be over cosine, this whole thing will be over 1, and you'll have to get common denominators to add them together. What is the common denominator? Well, since cosine's on the bottom, I need to multiply this one by cosine on the bottom and cosine on the top, multiplying by 1 creatively. And then it'll have a common denominator. Things will cancel out, and it'll end up working. When you multiply these together, the bottom becomes cosine. The top becomes cosine x times cosine x, which is cosine squared x. And this one over here, because it's over 1, will become sine times sine, which is sine squared x. And then you'll, on the top, have sine squared plus cosine squared, and you should know what that is. All right, I'm going to skip ahead to number 5 and just give you the one hint on number 5 I want to tell you, and that is, do you see a difference of squares there? Remember how you can factor that? We did that one in class as an example problem. That cosine to the 4th x minus sine to the 4th x. That can factor. I showed you how earlier. Got to remember how to do that. Okay. That's all the advice I have for you. I'll leave that up for anybody who wants to see it one last time.